Hey everyone, it's Jim from Valves and More, an online vintage tube store. And today in Tube Lab number 41, we're going to take a first look at coupling capacitors and why they're so important in your audio circuit. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. And if you're enjoying these videos, please hit the like button and subscribe. Before we get into coupling capacitors, we've got to back up a week and clarify my statement. Today, 6550 power tubes are basically KT88s. As you know, I love to bore everyone by pulling out data sheets. Well, last week I thought I could just roll on memory. Big mistake, and I'll show you why. Okay, let's just back up a little tiny bit. So here's the original GEC KT88 data sheet. And one of the things you got to watch out for, this one's from June 1961, they describe maximums differently during the years. They change the various ways that they will describe it. So 1961 to 2021 is 60 years of data sheets. So you have to look at what they're actually saying and interpret it, right? Sometimes you can't compare one data sheet to another directly without making an interpretation. So maximum ratings, absolute design maximum. You got to love it, right? So if you were a rock and roller tech in the 1970s, you wouldn't give a crap about design maximum. You'd be, let's go max, absolute maximum, plus 10%. See what happens. Anyways, so here we've got voltage on the anode, right, VA, which is also known as the plate, 800. We got VG2, so that's grid 2, which is the screen grid. Look at that, we're a lot lower, we're at 600. Other things we got to keep an eye on is plate dissipation. Look at that, absolute is 42 watts, and design max is 35. And we also got to take a look at, among many other things, IK here, which is K is for cathode, I is for current, right? So that's cathode current, but essentially what passes through the cathode is also passing through the entire tube, right? So that's plate current as well. So 230 milliamps, which is really quite high. Extraordinary, actually. So this is a high spec tube. Okay, let's keep going. We got lots to do today, we're backtracking. This is the Genelex. There you go. There's New Sensor, Long Island City, New York. At the time, I don't know where they are today. So this is their KT88. So this is a Russian KT88. And they just say maximum rating. So 600 volts, plate, 600 volts on the screen, 35 watts, maximum power, and 175 milliamps. So let's just back up quickly here. 35 watts. Okay, that's the same. But 230 milliamps and 175. That's quite a difference, right? And they're both KT88s. Okay, let's keep going. Now the 6550, which is in the KT88 family. They're all beam-powered tetrodes. In fact, I've got some around here. Where did I put it? Oh, here it is. Hang on. Let's get this up. A beam-powered tetrode is a 6V6, a 6L6, a 6550, a KT88, a KT90, a lot of different types of tubes. Now, what is that? Well, it's not an electrical connection. What it is a physical forming of the plate itself, right? Which is that jacket you see on the outside of the tube. We'll look at one in a minute and you can see it. So here they've actually done a lovely little drawing of one. So you see here it says beam plates, and they show you the electrons being focused here. So what you're getting is higher efficiency, which gives you the capability for higher power in the same basic envelope, right? Okay, so That's what your beam-powered tetrodes are, what they look like. So here's the Tung-Sol original data sheet for 6550s. So plate voltage is at 660, but look what they say here. Grid 2 voltage in DC, triode and ultralinear connection, which is very typical, is only 500 volts. Now, often when you tie the B plus or the plate voltage in triode and ultralinear mode, certainly in triode mode, you're going to use a small value resistor. So you're really not going to be able to run your plate all the way up to 660 volts. You're going to have it running at a maximum of about 500 volts because you're going to tie down here in triode mode, or in ultralinear mode you're going to have a tap on the output transformer. We're not going to go too deep on that part because it's a whole other video, and that's in the works too. Someday we're going to talk about triode and ultralinear mode. Plate dissipation is 42 watts, which is nice and high. But down here we got cathode currents 190. Let's go all the way back. Well, let's go to the Genelex, and that's 175. So it's even got, it can handle more current. Can it handle more voltage on the screen? No, it can't. The KT88 version can handle 600. Okay, let's keep rolling. I got one more here, and this is the crux of the matter. This is Electro-Harmonics 6550 that we were talking about last week. So plate voltage not more than, don't you love that wording? That's clear. 800 volts in tetrode mode, but we more commonly run them in triode and ultralinear mode. So 440 volts, so quite a bit lower. But lots of power dissipation, 44 watts in triode mode. And screen voltage not more than 440 volts. Now, I took the time to actually measure the Wilsonton R8, and the plate and the screen are both sitting around 446, 447 volts. So that's a couple of volts, a handful, let's say, right? A handful? That's where the word comes from. Or maybe this? I'm not sure. Anyways, a handful of volts is not normally going to be a problem. This is a recommended maximum. The engineers probably built in a small margin for error, maybe even a big margin. But to make sure, I've been running a quad of these really quite good sounding and very affordable 6550s in the Wilsonton for 2 weeks now, and they sound really good, and I haven't had a single problem with them, which is not surprising because they're basically sitting around maximum. The interesting thing about maximums is that sometimes tubes operate really well and sound really good when they're operating up near their maximum. That can vary. That's not a definitive statement, folks. Some tubes prefer a different operating point. We're actually going to talk about that in a design I'm working on in a minute. Okay, let's put that aside, and just for fun, let's just grab a whole bunch of these tubes and take a quick look at them. So this is an original General Electric 6550. Can you see that on the top there? It's still in place. I have a handful of these. These are a much loved 6550, and this is the Electro-Harmonics version. Look at the difference in the bottle size. Isn't that amazing? But the plates themselves, you see how they're shaped? See that? That's your beam formed focusing plate. So sometimes I'm lost for words. But much of the extra size here is not actually the plate. Even though the plate's a little bit bigger, the overall glass envelope is much bigger on the Electro-Harmonics, which of course is good for heat dissipation, right? Okay, what else have we got here? Here's another Russian. This is a KT88. This is the Genelex Gold Line brand. This is another one of those reissues from New Sensor. And look at the size difference of that. Now, I didn't dig out the data sheet on this, so I don't know how powerful KT88 is. But the point of what I'm trying to get at is, if you're going to swap tubes out, if you're really well within the norms of operation, you don't need to be too stressed about things. But if you're off on the fringes of the spec for the equipment, or the tube, you've got to get out your equipment specifications and the data sheet for your particular tube, and you've got to go over them, and you've got to pay attention to the wording of how they describe maximums, operating design maximum points, absolute maximums, all those things. Okay? Good. Let's move on. Today, I really wanted to take a first look at coupling capacitors, which all of these are, and figure out why they're some of the most critical components in any audio circuit. As you can see, they come in all sizes, values, voltages, and many different kinds of construction. The most common audio coupling capacitors are MPETs, and which are metallized polyesters, and MKPs, metallized polypropylene, which is this one right here. In fact, these are all MKPs here. So let's just take a quick look at them. Here's a paper, a Russian paper in oil. This is a 0.01 microfarad 600 volt, which is a fairly high rating for a small capacitor like that, but a lot of these metal capacitors were mil-spec. Here's a real monster. This one is a 0.047 microfarad, which is in the audio band. It's rated at 1,000 volts or a kilovolt, and it's another paper and oil Russian. Now, what's up with paper and oil? It's an older style of capacitor construction that many audiophiles swear by for tone quality. And one of the things I want you to take away from this is that your capacitor can change the sound. I know that sounds a little strange. Tubes can change the sound, rolling tubes, yeah, but capacitors can have quite an effect as well. Okay, here's a little tiny MPET. This is a Vichy. These are European. This is a series 1813. I use these quite a bit, and in my on my tube bench. This is a 0.1 microfarad 400 volts. This is quite a common coupling value. Here's another common value, another Vichy, and this is 0.22 microfarad 400 volts. This is, of course, is how they come in bulk, right? They come in a reel, on tape it's called. Sometimes they just come singly like these. This is what I've actually, we're going to look at the progress of my wee mono blocks. This is the actual coupling capacitor I'm using in that. And this is 1 microfarad 400 volts. And this is an inexpensive Chinese MKP. And this is 3.3 microfarad 400 volts. And I've actually got these in one of my prototype preamps, and they sound really quite good. And they're not expensive. Now, coupling capacitors do a couple of things. And we'll look at the primary thing on a schematic, but basically they block DC and they allow AC, which is the audio signal, to pass. But they can also affect the frequency band and act as filters. And these big guys here, these are all for my speaker building bin. I keep a whole selection of them, and when you're voicing a new speaker design, you're going to be changing coupling capacitors in value as you try to get the crossover component nailed to your satisfaction. So these are Solons. I think they're called fast caps, MKPs. This is 27 microfarad, which is very common value in a crossover, speaker crossover capacitor. Here's a bigger one. You can see as the value goes up, this is 47 microfarads, the voltage handling is lower. We don't actually need that much voltage in speaker crossovers, at least not small speakers like I like to build. But the common values for the MKPs tend to have fairly high voltages, which is fine. They can handle transients, and there's nothing wrong with using a higher voltage rated capacitor than you need, other than the fact they cost more and take up more real estate, right? And here's, I believe that's called an Odin. Odin, I guess. It's a German capacitor. Maybe I should say with a German accent, Odin. Anyways, these are quite nice. This is an MKP. This is 33 microfarad. They're beautiful to look at, aren't they? Some of the better quality capacitors that the manufacturers know will be on display. Some crossovers are on display. Mine are. I have open baffles, and the crossover network is sitting right on the back of the mid-range. Well, not on the mid-range speaker, but you know what I mean. Near the mid-range speaker, centered basically on my three-way design. And when I have guests over, many of them just want to take what the heck is behind that speaker? Well, there's nothing behind it. It's an open baffle, right? But I made a nice, neat job of building the crossover because I knew people were going to see them. Normally they're inside a box. And of course, all that gorgeousness is just lost, right? Okay, let's grab a schematic and see. Let's get it the right side up. So this is a working schematic for my 6P7S monoblock design, which is coming to fruition. And we'll talk about that in a minute. So as you can see, I mark up this sheet, and I've already messed up a couple of them. This is the latest version that's clean enough to work on. So let's do this really fast. We've got a driver stage here, single triode. It's increasing the voltage of our audio signal to drive the power tube, the 6P7S. We've got to connect that audio from this triode over here to this power tube. And we're going to take that audio signal off of the plate of our triode, and our plate has, I'm measuring 138 volts on it, right? Which is a fair amount of DC voltage. You can't put 138 volts and the AC audio signal onto the input grid of the power tube. Bad things are going to happen in a hurry. Remember, electricity moves just at sub-light speed, so that stuff is not slow. By the time you hit the off switch, it'll be too late. So, what we have is a coupling capacitor. This is really common between two stages. So, what this does, in this case, we got 1 microfarad, 400 volts. The voltage rating is always ample. You don't want that sucker anywhere near close to what your operating voltage is. I go as a minimum design spec 2.5 times. A typical voltage number that you'll find is 400. That's how we ended up with 400. It didn't actually have to be quite that high. So here's the actual capacitor that's in that amp. Here it is right there. You can see it's non-polarized. Here's a filter capacitor up here. It has to be, this is an electrolytic, it has to be oriented in the right direction, or you create a dead short. In fact, if you want to know more about capacitors, Uncle Doug has a fabulous video on YouTube. Watch Uncle Doug for the technical stuff. Okay, so here we go. So you can turn it around. It's the same capacitor, works exactly the same in either direction. So what that capacitor does is it blocks DC up to its rated voltage, right? And it allows the AC signal to pass mostly unimpeded. The capacitors will affect the sound. Now, they will affect the sound in the sense that they will add a slight amount of coloring or a slight amount of detraction. They do lower the amplitude of the signal very slightly, so there's a little bit of a signal loss coming through here, not much. And depending on the value, they can actually act as filters. So we were just talking about crossovers and speakers and how they're used as filters. In audio circuits like this, we've got to be careful. Now, a typical value in this position would be 0.1 microfarad. By going all the way up to 1.0 microfarad, I'm guaranteeing to pass everything in the audio spectrum and a little bit beyond. And the reason I've done that is I want to ensure that I get all of the bass. I want it all. If the circuit works fine, if the amp works fine, passing all of that audio signal and beyond, then I'm going to stick with that because I want everything. I don't want to cut it too close. Now, if I was having problems, I could take that and I could drop that all the way down to, let's say, 0.1 microfarad, and it would work just perfectly in the circuit. But it would act as a filter, and it would knock out some of the lower frequencies. Okay, so let's just put that aside. Let's clear the decks and see how the monoblock is coming along. And of course, before we go, coupling capacitors come in all different prices. Typically for a decent quality Vishay 1813 series, I pay, I don't know, $2.50 to maybe as much as $6-7 a piece at the most. For something like this, I might pay $30 a piece. And for paper and oil, I might pay 2 or 3 times as much. It all depends on the specifications, the manufacturer of the product, whether it's an exotic paper and oil product. You know, the sky's the limit. You could spend $200 on a capacitor like this to get something exotic. And whether or not it makes a huge difference in sound, I'll leave up to you, the viewer. It definitely does affect the sound, though. Okay, let me go grab the amp. Okay, we're going to have to back out. It's not that big an amp. It's a small, lower powered, single-ended design. We've talked about it before. But this is the right channel. So I've now got a pair. In fact, this morning I did my first stereo listening tests, and I managed to duplicate the first one, I think, perfectly, because the voltages are virtually identical using the same tubes. Right? The tubes will actually affect your voltage measurements. And the noise level is dead quiet. Now, these units, these prototypes still need to be bench tested to get me a couple of basic numbers. I need to know what the maximum output wattage is. I need to know what the frequency response is, and I'd like to know my noise number as well. But as far as a listening test on highly efficient speakers, my speakers are 93 dB plus. I use them actually to test tubes for customers because they pick out, I can hear the tiniest little noise going on inside those tubes. So if there's a problem, I usually weed them out before I ship. Sometimes some get through, and the bloody tubes don't develop a noise for a couple of weeks or a couple of days. Unfortunately, I can't test tubes for a couple of days. Some tubes I do, though, actually. My quads of Mullard EL34s, because they are such an expensive tube, and as a quad they're very expensive, I actually listen to those for days just to ensure that I don't have a problem. And they are solid tubes. I've actually never had one fail, touch wood, and they're just rock solid. Mullard made some really good quality tubes. And great sounding EL34s, amazing sounding. Okay, back to the amp. So here's something fun. So normally I drill out these little ventilation holes. It's a design feature, but I like to have them. I like the fact that it allows the hottest portion of the circuit to actually have room to vent. And I drilled them a little small. Normally I oversize them from my pilot size. And what I ended up with is a snug fit. See that right here? Let me get it up here. See that? It goes through, but just barely. And the nice thing about that is if somebody jerks on this cord, I couldn't figure out a way to get a strain relief. Let's flip it over so you can see what I mean. So I couldn't figure out how to get a strain relief on that without going all crazy. And I like simple designs. I don't like things complicated. Complicated, fiddly stuff drives me insane. So these things are now snug in the hole. So I have a feeling that's how I'm going to make this, because this is, of course, this is a prototype design, but it's going to, in the next stage will be a pre-production build to ensure that the actual kits, I'm hoping with the help of my son that we can make these up as kits. I think that'll be an actual improvement. Now, the interesting thing is, when you build the second version, you often will find some, various little problems and things like that that you need to work around. And it was perfect. Other than the fact that the biasing on the driver tube was wrong, it sounded great. You can misbias triodes every which way, and the bloody things will still work and sound good. But the operating point wasn't centered the way I would like to see it. So it took about a half a day to get it centered. And changing out various values of components and doing some more testing. And eventually I got it right. And the reason I goofed it up the first time is I didn't look at the data sheet. I biased the tube for 6J5 thinking it was really close, and it turns out it's actually not that close, at least as far as the plate characteristics are concerned. It was a development of the 6J5. And it's one thing to say these things, but it's another thing to be smart enough to pull out the data sheets and check. Anyways, I did that yesterday. I got it bang on. And so how does this sound? That's the big thing now. I've listened to it in mono. I was really impressed. Now I finally listened to it in stereo. And we'll probably do a full review, so we're just going to keep this brief. It sounded fantastic. It had, like a lot of lower powered single-ended designs, it had an amazing amount of clarity. And with clarity comes soundstage. The soundstage was unbelievably good. I would say it's the best soundstage of any amp I've ever built or have owned. It was that good. Now, part of that is probably the tubes. We're still not sure whether, I think I've got the Russian tubes in here. These are Svetlanas, which are beautiful sounding tubes, but I've got either our Marconi CV6 or a Mullard CV6. I'm still not certain. I'm leaning now towards Mullard, which is nice because I have a nice selection of them. And those tubes sound fabulous as well. This power tube, this is a wonderful little beam tetrode. It sounds great. Now, it is wired in triode mode. And this is not a switchable amp. That's how it is going to stay wired. That's my favorite mode for a little single-ended amp like this. So anyways, that's a great success. I'm going to keep moving this along, and eventually, hopefully, it'll be out as a kit. Okay, that was fun. Let's just put this aside and see what came in this week. One of mine and many favorite 6SN7s. A whole bunch of these came in. Now, they weren't cheap. And this one doesn't have a label on it, which is pretty common of vintage tubes. The labels just get cleaned off by some aggressive picker. They think the tubes are more valuable clean than dirty with a label. So these are Tung-Sol. They are the big tall bottles. Most of them, not all of them, but most of them have the horseshoe getter. Some of them have a round halo getter. And a lot of people consider this to be their favorite 6SN7. I put it in sort of the league of the Sylvania sound, the 6SN7 GTA and GTB. They're not the same. They're a little bit different. Anyways, quite a few of them came in, and quite a few match pairs are in the store. Let's just take a quick look at the tube. Let's see if we can get it to focus close up. The way to tell a real Tung-Sol is the mica spacers. You see what look like little tiny teeth or dinosaur claws all the way around? Well, those, of course, are helping nest the tube inside the envelope. And a few manufacturers use this, but Tung-Sol made this kind of their own. And that's a good identifier. And let's see if you can see the getter up there. See that kind of a horseshoe shape? That's another good indicator, though some of them did come in round. And of course, it's nice if it has a label. Some of them were rebranded. So that's why I'm showing you those identifiers. Okay, folks, if you stayed till the end, here's some discount codes you can use. Remember, I've got flat rate shipping around the world of $20 and free shipping on orders over $150. And I thought I should give everybody the heads up. There is a secret discount code that hides in the store. I haven't talked about it in the past. I haven't whispered it to, well, maybe one person guessed. No, 2 people guessed. I bet you can figure out what it probably is. Anyways, I thought it would be fair to tell you because a couple of people have been using it. And I think it's fair that everybody is on the same level playing field. Anyways, that's your tip for the day. Stay safe, everyone. This is Jim from Valves and More signing off. Cheers, everyone.